Hello, this is Peter Carter here for the Climate Emergency Institute. This is actually a presentation which I've updated. I gave this at the EGU assembly in Vienna in April of 2017, and it's based on data research up to March of 2017. That is the atmospheric greenhouse gas pollution indicators and the directly observed effects. Now, I've updated it because of the El Nino effect. So the title of the video is 2016 to early 2017, the climate and oceans record highs and record rates. And the subtitle is the Planetary Emergency and the El Nino Effect. This is very important because there are several published papers showing that El Ninos will increase with global warming, and in addition to that, they will feed back on climate, as indeed the El Nino of 2015-2016 did, and this shows up in the data. For an example of very worrying research is 2017 research, the paper entitled Increase in Extreme El Nino Frequency Long After 1.5 degrees C Warming Stabilization, and this was a very big increase in the El Nino effect. So going through the presentation here, first we have carbon dioxide, and this shows accelerating atmospheric CO2 from 1960 to March 2017. I should say that the benefit of putting all this in one image is that it's immediately obvious that everything is getting worse, and it's getting worse fast. You just have to take a look at all of these all together. So, of course, atmospheric CO2 is the very most important data that we're following. The 2015 and 2016 one-year atmospheric CO2 increase was 3 ppm, which is a stunning increase, and it's unprecedented in Earth history. The reference for that is Andrew Glickson, paleoclimatologist, 2016. So here we have here we have 1960, and this is up to 2017. This record is from the Scripps Institute of Oceanography. I've extended it down here a little bit to 300 ppm CO2, and it goes up to 400 and more, because the atmospheric CO2 concentration in 2017, early 2017, was 406 parts per million, and it's clearly accelerating. The 300 parts per million here is the 800,000 year ice core limit. So we are way above the atmospheric CO2 limit for the past million years. 2015 and 2016, there was a jump in the rate of acceleration, and this was the El Nino boost effect. The El Nino being a phenomenon of ocean surface warming in the Pacific. This is the global surface warming, showing that rapid global warming continues and increased markedly in 2016. This record is from 1880 to 2016, and it's from James Hansen and Sato, dated 18th of March 2017, their record at the Columbia Earth Institute. So from 1900, clearly the global surface temperature is accelerating, and it reached an all-time record, an annual record of 1.25 degrees C in 2016. The linear trend from Dr. Hansen gave 1.19 degrees C, and again this big boost is from the El Nino effect acting on top of global surface warming from steadily increases in atmospheric greenhouse gas concentrations. The effect of the strong El Nino causing a big surge in atmospheric CO2 concentration and global surface temperature was due to three massive tropical forest regions, namely the Amazon rainforest, African forests and jungles, and Indonesia. In the Amazon, the rainforest stopped taking down carbon dioxide, meaning that more carbon dioxide was left in the atmosphere. So that was the failing of the Amazon huge carbon sink due to the El Nino. In the tropical jungles and forests of Africa, record warmth and rain combined to speed the decomposition of plant debris, and that increased CO2 climate warming emissions. And in Indonesia, the hot and dry conditions helped spur intense fires that burnt deep into the carbon-rich peat soils, releasing more CO2 and more methane. So the message of the El Nino is extremely important and serious. If those forest regions respond to global warming, respond to the increase in global warming by our human industrial activities in the same way as they did during the 2015 El Nino temperature spike, they will become net sources of CO2 instead of carbon sinks. Add to that it is projected that global warming will increase these El Ninos, and we have a huge planetary emergency situation without any question. This one here is the most recent one that I had for this EGU presentation. It runs, it shows 2016 and February 2017, and this is from the NASA GISS. And the 2016 data was 1.19 degrees C, as you see here. And February, it jumped up to 1.37 degrees C, which is absolutely phenomenal. Subsequently, of course, it has settled back. But this shows the extreme impact of El Ninos on top of atmospheric greenhouse gas global surface warming. Here is fossil fuel CO2 emissions from 1980 to 2016, reported by the International Energy Agency. And fossil fuel CO2 emissions went flat from 2014. They didn't increase any further. They have increased again now. This was a very great concern because the atmospheric CO2 concentration was still surging. Here shows the extreme escalation of atmospheric greenhouse gases. Carbon dioxide here on the left, and on the right is methane, CH4. And carbon dioxide was affected by the El Nino, 406 parts per million. The pre-industrial concentration was 278 parts per million. Methane recorded from NOAA at this time was 1,840 parts per billion, and its 800,000 year limit is 800 parts per billion. So atmospheric methane has substantially more than doubled since the pre-industrial, and also over its 800,000 year limit. This one here is the sea ice. It shows the Arctic sea ice on the left here and the Antarctic sea ice on the right. And sea ice in both poles is melting fast. In actual fact, there was a record Arctic winter low in March of 2017, and a record Antarctic summer low in, again, March of 2017. This bottom row here is the ocean, and there's an increasing rate of ocean heating. This is from NOAA. This shows the deeper ocean, 2,000 meters, and the ocean heat content is accelerating. This shows the increasing rate of ocean deoxygenation. This is an effect of ocean heat, and I should have said that the ocean heat runs from 1960 to December of 2016. This increasing rate of ocean deoxygenation, shown here, is from the IPCC. It runs from 1900 up to 2015. The IPCC report was 2014, and I've just taken the projection for the next couple of years. And this shows that overall the deoxygenation rate is also accelerating. This is an average. It varies according to the ocean regions. So next is ocean acidification. Ocean acidification is also accelerating. The reference for that is the World Meteorological Agency that did a special report on ocean acidification in 2016. This dramatic visualization of ocean acidification is from Will Stephan, published in 2015. One of his papers on the Anthropocene. To bring this up to date, I've gone to the Japan Meteorological Agency, which is, I think, the best source for ocean acidification. And this is the pH here on the vertical axis. And as the pH drops, ocean acidification increases. So I've reversed this and moderated it a little bit, which gives you the picture of the ocean acidification trend. The last one here is sea level rise. Sea level rise is also accelerating. This I've taken from the IPCC and similarly given it a couple of years on the projection to bring it up to date for this presentation. This runs from 1900 to 2016. So the overall picture here is that all of the greenhouse gas pollution indicators and these direct observed effects are increasing as fast as ever, and the most important ones are accelerating. So that's the big message here, and it's a very, very bad message, and it's proof positive that we're in a planetary Earth emergency, and this emergency is made much worse by the prospect of increasing powerful El Ninos and the El Nino effect.